Welcome students. In this video we are going to see some revision sums on grade 10 real numbers, first chapter real numbers. The first question we are going to discuss here is if two positive integers a and b are written as. Here we have a is equal to x cube y squared and b is given as b is equal to x y cube. These are the two positive integers given. Here the description is x and y are prime numbers. Both are prime numbers. Then HCF of AB. So we need to find here HCF of AB. We are having four options. In all the four options we are having x and y. First you have to know what is HCF. HCF means common factor, only the common factor. Okay, so only common, we need to choose only the common factors. In that common factor, least power of the common factor we have to choose. HCF is nothing but only the common factor. If different powers are there, we have to choose the least power of the common factor. Here we are having x and x. X is common for both the numbers. What is the least power? X for a, x cube is there. For b, x simply x is there. X power 1 is there. So least power is x. Then when you are seeing y also common here. Both the numbers are having y as the factor. For a, y's power is 2. For b, y's power is 3. So least power 2. So HCF of AB is nothing but x y squared. So here the correct option is B. B is the correct option, x y squared. This is our correct option. Question number 2. Find the greatest number of 5 digits that will give us remainder 5 when divided by 8 and 9 respectively. So here we are having 4 options. Check all the 4 options whether we are having 5 digit numbers or not. All the 4 options we are having 5 digit number. So among this we need to find which number can divided by 8 and 9. We both the numbers. When we are dividing 8, we need to get remainder as 5. When we are dividing 9 also, we need to get remainder as 5. So for that you no need to check separately. Easiest way, find the multiple of 8 and 9. 8 9s are 72. Now divide each number and check. Option A, when 99,921 is divided by 72 means we will be getting, we can divide that 1387 times. You can check. When we are dividing that with 72, we are getting remainder 57. So this is the improper fraction. 1687 57 by 8, which means division, when we are dividing the quotient we are getting here, quotient is 1387 and the remainder here is 57. That is 1387 into 72, we are getting 99,864. Then adding 57, we will be getting our record number. That is 99,921. So 99,921 can be splitted as 1387 57 by 72, which means when we are dividing that number by 72, we are getting the remainder 57. So A is not the correct option. Let's check B. So 9931 divided by 72, the same 1387, we are getting 67 by 72. 67 is the remainder. Here remainder 67, which means 1387 into 72, we are getting 99,864. Adding 67 with this, we are getting 1 and 2, 3, then 9, 9. Yeah, we are getting the third subdivision. So remainder is 67. B also not the correct option. Then 10, 10 number. Look at here, from option 1 to 2, A to B, 10 number increased, and B to C, one more 10 number, C to D, another 10 number increased. So when we are dividing 9, 9, 3, 1, 4, 1 divided by 72, we can increase the remainder. Here remainder is 57, here remainder is 67. So definitely here we will be getting remainder 77. When we are dividing 72, the same number 1387, if we got the quotient, means we will be getting remainder 77. So one more time we can divide. So the quotient here is 1388. 88 means the remainder here is 5 by 72, which means 1388 into 72. Product of these two will give 99,936 plus 5, we are getting 99,941. So here we are getting remainder 5. That means what? For the option D, 99,951 divided by 72, we will be getting same quotient 1388, but 10 number increased, 41 to 51, 10 number increased. So remainder also we need to increase 10 numbers. So here remainder 15. So our correct option is C, that is 90. This is our correct option. 99,941 divided by 8 or divided by 9. 8 and 9 both, we will be getting remainder as 5. So we are multiplying 9 and 8 and 9, and we are getting 72. Then we multiplied here. We are getting the quotient 1388 and the remainder 5. So our option, correct option is C. Third question. The ratio between LCM and HCF of 5, 15, 20. So both we need to find LCM and HCF. Factor of 5 is 5. Factor of 15 is 5 into 3. 3 5s are 15. Factor of 20 is 5 into 4. 4 can be written as 2 squared. So HCF of 5, 15, 20, common factor. So only the common factor here is 5. 3 and 2 are not common for 5, 15 and 20. So only 5. All the numbers are having same powers. So HCF of 5, 15, 20 is 5. Then LCM of 5, 15, 20. What is the LCM? LCM is nothing but common factor in that common factor highest power. When we are choosing common factor, we need to get the highest power and non-common factors also. Non-common factors also. Product of common factors highest power and non-common factor is the LCM. Here common factor same power, so 3, and non-common factor 5 is there and 2 power 2 is there. These are the non-common factors. So 3 5s are 15. 15 into 4 we will be getting 60. So HCF is 5 and LCM is 60. They are asking the ratio. Whenever we are writing the ratio, the order is very important. Here they are asking ratio between LCM and HCF. Don't change the order. That is LCM is to HCF. After finding this, don't find the ratio 5 is to 60. 5 is to 60 is HCF is to LCM. That is wrong. Order is wrong means your answer also wrong. Don't write that. So when we are finding the ratio, we have to very careful about the order. So LCM and HCF means LCM is to HCF. LCM is 60 is to HCF is 5. When we are reducing this, 5 table is common. So 12 times 5 will divide 60. 12 is to 1. So our correct option is D. Option D is the correct answer for this question. Next question, fourth one. Two alarm clocks ringing their alarms at regular interval of 50 seconds and 48 seconds. If they first peep together at 12 noon, at what time will they peep again for the first time? So what is given? Alarm 1 ringing every 50 seconds and alarm 2 ringing every 48 seconds. So different timing, for different timing, their duration, different duration, the alarms are ringing. At one situation, both will ring together. So 12 noon, they are ringing together. Then they are asking, after that, after 12 noon, what is the first time they will ring together? What is the time they are asking? So here we are not arranging anything, we are collecting something, that is 50 and 48. What is the common number? Next common number we are collecting. Whenever we are finding the collection together and collection, we need to find the LCM. Arrangements and order, we need to find HCF. So here we need to find LCM of 2 seconds, that is 50 second and 48 second. For these 2 seconds, we need to find the LCM. So for 50, 2 times 25 and 5 into 5 is the prime factor. For 48, 2 times 24, then 2 times 12, then 2 times 6, then 2 times 3. So which means 50 is equal to 2 into 5 squared. Then 48 is equal to 2 power 4 into 3. Now we need to find the LCM. So LCM common factor, in that common factor highest power 2. Both the numbers are having factor 2. In that highest power is 4. So 2 power 4 into non-common. 5 squared is non-common. 3 is non-common. 3 into 5 squared. So 2 power 4. 2 power 4 is 8. 8 into 3. 5 squared is 25. So 24 into 25. So what is the product of 24 and 25? So 20 remaining 2, 120, 8, 4. So we will be getting 0, 600. So 600 seconds. Question number 4. 2 alarm clock ringing their alarms at regular intervals of 50 seconds and 48 seconds. If the first peep together at 12 noon, at what time will they peep again for the first time? So what is given? Alarm 1 ringing 50 every 50 seconds. Then alarm 2 ringing every 48 seconds. So different duration, the two alarms are ringing. At some duration they will ring together, because 50 and 48 are having common multiple, so that they will ring together definitely. 50 and 48 will have the common factor, that so at 12 noon if they are ringing together, means after that, which is the next duration they will ring together, we need to find. So collectively we are finding something. When we are arranging something, we have to find HCF. When we are collecting 50 and 48's common number next. So when we are collecting something, we need to find LCM of the two numbers, that is LCM of 50 and LCM of 48. For that, first find the factors, prime factors. 50 2 into 25, so 2 into 5 squared 50. What about 48? What are the factors for 48? 48, 2 24, then 2 12, then 2 6, then 2 3, which means 2 to the power 4 into 3. Now for finding LCM, we know very well for the LCM, when we are having common factor, here 2 is common for both the numbers. In the common factor, we have to find the highest power, that is our LCM. So when LCM, to find LCM in common factors, highest power into non-common factors also, that is our LCM. HCF means only the common factor, in that least power we need to take and multiply all the common factors with the least power. But in LCM, to find LCM, we have to find the common factors highest power and non-commons also. 3 is non-common factor and 5 squared also non-common factor. So 2 power 4 is 16. 16 into 3 into 25. Now 16 into 3, 48. 48 into 25. So when we are multiplying 48 and 25, we will be getting 48 into 5, 240 and 96. 2 into 48, 96, 0, 0 and 1200. So 1200. Now what is this? 1200 is what? We are finding the 50 seconds and 48 seconds. Common multiple of 50 seconds and 48 seconds. So 1200 seconds. LCM of these, that is next common multiple is 1200 seconds. After 12 noon, after the 12 to 1200 seconds, it will ring. Now we can convert this into minutes. So when we need to convert a second into minutes, we need to divide that by 60. What is the number is there? Seconds by 60, we will be getting minutes. So 0, 0 cancel. So 20 minutes. That is 1200 seconds, nothing but 20 minutes. So LCM of 50 and 48, either 1200 seconds or 20 minutes. Just we are converting. So we cannot convert this by hours, because only 20 minutes is there. So after 12 o'clock, after the 20 minutes, both the alarms will ring together. So 12 hours, 20 minutes, the alarm will ring together. Here all the option given as PM, 12:20 PM, 12 PM, 12:11 PM, none of this. So the correct option is A, 12:20 PM. So next we can hear both the alarms can ring together. After 12 o'clock at 12:20 they will ring together. Fifth question, HCF of 2472, 1284 and a third number n is 12. That is, what is given? HCF of three numbers 2472 and 1284 and the number n. So their HCF is 12 is given. If their LCM is, that is LCM of 2472, 1284 and n is equal to 2 power 3 into 3 power 2 into 5 into 103 into 107. This is the LCM. Then the number n is, three options are there. From that three option, we need to choose one. So find the prime factor, because HCF is given, LCM is given, HCF is 12. 12 is nothing but 4 3s are. So 2 squared into 3. The prime factor of 12 is 2 squared into 3. Now 2472, we need to find the prime factor for this, and 1284 prime factor of this. Then we can get the number, because all the option we can see the prime factors. So find the prime factor for 2472. So 2 table, 1 time, 2 time, 3 time, and remaining 1 6 times. Next 2 6 times, 1 remaining 1 8 times. Next once again 2, because even numbers, so we can take 2. 3 times, and very particularly we cannot divide 1 by 2, so we need to put 0. This is very important. We have to, when we cannot divide a number, we have to put 0. This is not 39 into 2, that is 39. If you are not, next to 18, 9. So 309 into 2 only 618. If 39 into 2 means 18, 78. Only we will be getting 78. So here writing 39 is the wrong answer. Whenever we cannot divide a number, we need to put 0 there. Otherwise, you multiply. 2 into 39 is what? 2 into 309 is what? 2 into 309 only 618. Next 3 table, 103. Now 103, we cannot divide this 103. 103 is a prime number, so leave it. So the prime factor of the first number 2 power 3 into 3 into 103. Then next number, the next number 1284. So 2 table, 6 time, 4 time, 2 time. Then 2 table, 3 times, 2 times, 1 time. And then again 3 table we can take 1. Again we cannot divide 2. We cannot divide 2 by 3. So we need to write 0. Then 7. Otherwise 17 into 3 you can get 21, 51. So this is wrong. 107 into 3 we can get 321. Now 107. So prime factorization, 107 is a prime number. 2 squared into 3 into 3 into 107. So these are the two prime factors of the first two number. Now next number, look at the HCF. HCF we are having 2 squared and 3, which means that is the common factor. 2 squared should be common in all the three numbers. All the three numbers, definitely we need to get 2 squared. And when we are seeing here LCM, 2 power 3 is there. So 2 power 3, here we can see 2 power 3 is there in the first also. So yeah, for our in this play here, either we can get 2 squared or we can get 2 cube. Both the chances are there. In your options, 2 squared is there and 2 cube is not there. Look at the D option, 2 power 4 is there. So 2 power 4 is not at all the prime factor of the three numbers. So definitely this option will not come as the answer. Leave it. Now we need to check these three options. So first number we can decide 2 squared. because all the three options are having 2 squared only. So first prime factor here 2 squared. Then 3 also common. HCF we are having 3, and look at LCM. LCM we are having 3 squared. So here we are not having 3 squared in first two number. If all the three number, the highest power is there, then only it should be there in the LCM. So definitely here we need to get 3 squared. Now look at the option. Definitely the next number, here 3 is there, here also 3 is there, but in our LCM 3 squared is there. So definitely n should have 3 squared as its prime factor. Look at the option. So first option 3 squared is there, second option 3 squared is not there. So strike it out. This is also not the answer. So now our answer is either A or B, C, because C also 3 power 2 is there. Now check the next number. That's all the common factors. Now only we are having non-common factors. In our LCM, 3 non-common factors are there. 5 is a non-common factor, 103 is a non-common factor, 107 is a non-common factor. Look at here, 103 is there, 107 also is there, 5 alone is not there in the non-common factor. And your option also we are having 5 in option C, but option A 7 is there. 7 not at all the prime factor for the 3 numbers. So only we can get 5. So this is our n. So the correct option here is option 3, C. Option C is the correct option. So the number n should have prime factor 3 squared, 2 squared, 3 into 3 squared into 9. So 4 into 9 into 5. So 9 5s are 45 into 4. That is the third number. Sixth question. Two natural numbers whose difference is 66 and the least common multiple is 360. So here all the options we are having natural numbers. So first check whether we are getting the difference is 66 or not. Now 120 minus 54, we are getting 66. Here 90 minus 24, we are getting 66. Then 180 minus 114, we are getting 66. Then 130 minus 64, here also we are getting 66. So we cannot leave any option. We need to check all the options, because difference of these two natural numbers, we are getting 66. We are getting 66. Now we need to find the multiple. Least common multiple is 360. So we have two way we can find. One way we can find for option A, we can find LCM of 120 and 54. What is LCM of 120 and 54? Like this also we can check. Otherwise, to finding LCM, we can check whether 360 is the LCM or not, because they are asking least common multiple. Otherwise, we can divide 360 by 120. If it is dividing exactly, yeah, it is divided exactly, it is dividing. And 360 by 54, can we divide it exactly? 54 into what? 54 5s are what we are getting? 54 5s are 20, remaining to 270. So yeah, we are not getting 54 into 5. 54 into 10, we are getting 540. So here we are not getting exact number. So we are not getting whole number. So 360 cannot divided by 54 exactly. So option A is not the correct answer. Then 360 divided, you can find LCM of 90 and 24 and check it. Otherwise, divide like this 4 times. Now 360 divided by 24, check 24 into 5, remaining 2, 10, 120 only given. 120 we got. 24 into 10, 240. Check for 24 into 15. So 120 and 4 and 2, yeah, we are getting 360. That is 360 divided by 24, we are getting exact number 15. Likewise, check for 180, 360 divided by 180, 0, 2 times. And 360 divided by 114, definitely we cannot get 5 times when we are checking 5, because unit place is 0, so that I am checking either with 5 or with 10. 20 remaining 2, 7, 5, 570. So we cannot get exact divisor there. Now these two numbers 360 divided by 130, we cannot get the exact number. So 13 twos are 26, 13 threes are 39. So here itself we are not getting. So the correct answer option LCM of 90 and 24 is 360. You can check that also. 90 we can write 2 into 3 squared into 5. So 9 5s are 45, 45 twos are, and 24 you can divide and write 24 2 if we are taking 2, 12, then 24 2 12 2 6 2 3, 2 power 3 into 3. So LCM highest factor, that is 2 power 3 into 2 squared into 5. So 2 power 3 is 8 into 9 into 5. So 40 into 9, 360. So LCM we are getting 360. So the correct option here is B. The numbers 90 and 24 will have the difference 66 and common multiple 360. Seventh question, HCF of 5 squared, 3 squared and 3 power 5, 5 power 3. So 5, the numbers we don't know, they gave the prime factors 5 squared and 3 squared and 3 raised to the power 5 into 5 raised to the power 3. Now common factor, HCF means common factor in that common HCF of 5 squared into 3 squared, comma 3 power 5 into 5 power 3. Common factors least power. So 3 power 3 squared and 3 power 5. These twos are common. In that least power is 3 squared. So 3 squared. Then next common 5. 5 also common factor. So 5 squared and 5 cube. In that least factor 5 squared. So the option D, 5 squared and 3 into 3 squared is given. So correct option is D. 5 squared into 3 squared and or 3 squared into 5 squared, both are same answers. So we don't need to check the order in addition or multiplication. Addition and multiplication both are commutative. If we are changing the order also, we will be getting the same answer. Eighth question, HCF and LCM of 12, 21, 15 respectively are. So find the factors. 12, 4 3s are 12, so 2 squared into 3. Then 21, 3 7s are 21. Then 15, 3 into 5, 3 5s are 51. So now we need to find HCF of 12, 21 and 15. So common, which is the common factor here? Only 3. 3 is common for all the 3 numbers. Only 3 and same power. So HCF of these 3 numbers, only 3. And what about LCM? LCM of 12, 21, 15. The common factor with same power 3 and non-common. 3 non-common factors are there. So first non-common factor 2 power 2 and the second non-common factor 7 and third non-common factor 5. Now 3 into 4, 2 power 2, 4, and 7 5s are 35. Now 12, 3 4s are 12 into 35. So what is the product? 35 into 12, 10, 70. So 5, 3, 0, 12, 420. So the product is 420. So HCF is 3 and LCM is 420. Now look at the options. Option A, 3 and 140, that will not come. 12 and 420 also will not come. Here option 3, option C, 3 and 420 is there. Option D, 420 and 3 is there. So which one we can choose here? For that, they are giving HCF and LCM of this respectively, which means first number should give HCF of these three number, second number should give the value for LCM. So this is HCF, this is LCM. So here when we are seeing, this will be HCF and this will be LCM. So this is not correct answer. So the answer is HCF and LCM of these three numbers 3, 420. This is the correct answer. So option C is the correct one, not option D. Respectively is given. So in the correct order, we need to choose the answer. Next, assertion and reason. You know very well, assertion and reason will have 4 options. Option A, assertion is correct, reason also correct, and reason is the correct explanation of the assertion. Option B, assertion is correct and reason also correct, but reason is not the correct explanation of assertion. Option C is assertion is right and reason is wrong. Option D, assertion is wrong, reason is correct. So these are the 4 options. We will check for this. What is the option we are getting? So what is given? Assertion. 9th question. Assertion is for no value of n, where n is a natural number. N is a natural number. The number 6 power n ends with the digit 0. So when 6, for example, 6 power n, what they give? Any natural number. So first natural number 6, we will be getting 6 power 1. Next number 2, 6 squared, 36. Next number 3, 6 cube, 216. So like that we can find any number. But we know very well, after learning the first chapter, we know very well a number, we need to find the prime factors for the number. 6 prime factor is 2 into 3. So 2 power n into 3 power n. So we are not having combination of 2's, 2 as 5. If we are having 2 into 5, we will be getting 10. So that we will be getting in unit digit 0. Here we are not getting 5 as the prime factor for 6. So the assertion is correct. So no value of n, the number ends with the digit 0. No value, any value. If suppose 6 power 10 given also, we will not get the number which ends with the digit 0. We cannot get, whatever it may be, because in the prime factorization there is no 5. Assertion is correct. What is the reason? For a number to end with the digit 0, its prime factorization should have 2 and 5. Yes, this is the correct explanation of the assertion. So we need to choose the option A. Assertion is right, reason also right. Reason is the correct explanation of the assertion. Then question number 10. Assertion is LCM of two number is 2475 and their product is 12,375. Then their HCF is 5. So what is given? We don't know two numbers. Say two numbers. HCF of that two numbers x and y is 5. Then LCM of the same numbers 2475. And one more information given, product of the two numbers, that is x into y is equal to 1 to 12,375. We know very well product of two numbers is equal to HCF of the two numbers into LCM of the two numbers. We know this very well. So we check. We are having product. We are not having separate two numbers. We are having product. We check 5 into 2475. When we are multiplying, 5 5s are 25, remaining 2, 5 7s are 35 plus 2 37, remaining 3, 5 4s are 20 plus 3 23, remaining 2, 5 2s are 10 plus 2 12. So same 12,375 we are getting. So assertion is correct. Then what is the reason given? HCF into LCM of AB is equal to A into B. Yeah, we took x and y. So HCF of x and HCF of xy into LCM of xy is equal to x into y we got. So reason also correct. So same A as the answer. Assertion is right, reason is also right. Assertion is the correct explanation of the reason. Now let's see one case study. Case study 1. To enhance the reading skill of grade 10 students, the school nominates you and 2 of your friends to set up a class library. There are two sections, section A and section B of grade 10. There are 32 students in section A. So number of students in section A 32 and number of students in section B 36. Section B. So what is the first question? What is the minimum number of books you will acquire for the class library so that they can be distributed equally among students of section A and section B. So we need to buy minimum number of books so that we have to distribute all the students. So we need to find what, again it is a collection. So we have to find LCM of 32 and 36, because if we are finding HCF, only we will be getting common number. With that common number, how can you distribute a book to all the students? So we need to distribute all the students a book. Minimum number means what is the common multiple of 32 and 36 we have to find. So find the prime factors for 32. 32 is nothing but 2 power 5. Then 36, 9 4s are 36. So 2 squared into 3 squared. So LCM of 32 and 36 for the common factor. Here we are having these are the two common factors. Highest power is 2 power 5. Highest power 2 power 5 into non-common 3 square. So 2 power 5 32 into 9. So 32 into 9. 32 into 9, 9 2s are 18, remaining 1, 27 plus 1, 28. So LCM of 32 and LCM of 32, the common multiple, first multiple of 32 and 36 is 288. So minimum 288 books they need to buy so that they can distribute equally among the students of section A and section B. Look at the next question. If the product of two positive integers is equal to product of HCF and LCM is true, then HCF of 32 and 36. Previous sum we got LCM of 32 and 36 is equal to 288. Previous subdivision. We know that product of two numbers is equal to Product of HCF of the two numbers into LCM of the two numbers. So here we are getting HCF. We don't know HCF of 32 and 36, but we know LCM of these two numbers is 28. Then multiply two numbers, 32 into 36. So to find the HCF of 32 into 36, we can transpose 288 to next side and divide 288. When we are transposing, we can cancel this 9 times and we can cancel this 4 times. So HCF of 32, 36 is equal to 4. They asked this way so that we are finding. Otherwise, directly you can find. 36 can be expressed as product of its prime. Yes, of course. We already expressed 36 is 2 squared into 3 squared. 4 9s are 36. So product of primes. 2 and 3 both are prime numbers. We expressed 36 as product of primes. Next question, 17 into 13 into 11 into 7 plus 7 is dash number. Here 17 is a prime, 13 prime, 11 prime, 7 prime. Product of prime is a composite number, we know very well, but addition is here. So we need to check whether we are getting product of prime or not. By the fundamental theorem of real numbers, product of prime is a composite number. We need to check we are getting product of prime or not. Now, two way you can check. As it is, you can multiply and get the answer. Then try to get the prime factorization for this. Now, multiplying 17 into 13, we will be getting 221. And 11 into 7, 77 plus 7. And multiplying 221 into 7, we will be getting 17,017. Then 7, we are getting the answer 17,024. Now we need to check, we can express this product of prime. Yes, of course, we could express this. What are the prime factors? 2, 8 2s are 16, remaining 1, 5, 1 time, 2 time. Then 2, 4 time, 2 times 4, remaining 1, 5, remaining 1, 6. Then again 2 times 4 and 1 time 2, 2 times 4, remaining 1, 8 times 6. Then 16, 2, 1 cannot be divided, 1 cannot divided by 2, so 0. Now 12, 6 times, then 4 times. Then 2, 5 times, 3 times, 2 times. Then 2 times, remaining 1, 6 times 12, remaining 1, 6. Then again 2, 1, 3, 3. Now 133 is not a prime number, but we cannot divide that by 3 and 5. Now 7, we can divide this by 7. So 7 into 1 times 7, remaining 19 times. Now 19 is a prime number. So we can express 17,024 as 1, 2, 3, 4, 5, 6, 7. 2 to the power 7 into 7 into 19. So product of prime. Now we wrote product of prime. So product of prime which gives the composite number. So our number is a composite number. The given number is a composite number. You can check this the next way also. 17 into 13 into 11 into 7. Another method is look at the right hand side of addition. We will be having one term and another term. Both the terms 7 is common. When we are taking 7 is common, now we are getting 7 times 17 into 13 into 11 into, instead of 7 we can replace 1 and here also 1 because we took it as common because that is the prime number, so we can separate it. Now we are having 17 into 13, 221 into 11, 11 into 1, 11 plus 1. Now 221 into 11 is 2431 plus 1. So we are having 7 into 2432. Now what are the prime factors for 2432? 2 times 2 table 1 2 1 remaining is 6 times, then 2 table 6 times 0 8 times, then 2 3 times 0 2 4 times 8, then 2 1 time remaining 1 5 times 2, then remember 2 7 times 14, then 6 once again 2 3 times and 8 once again 2 1 time and 9 times. Now that's all. 1 1 2 3 4 5 6 7. So we got the same answer, 7 into 2 to the power 7 into 19. Now product of prime is the product of prime, so that we are concluding the given number is a composite number. We can express the given number as product of prime, so that we can conclude the given number is a composite number. Next question, if P and Q are positive integers such that P is equal to A and Q is equal to B, where A and B are prime numbers. So here P is equal to A and Q is equal to B. A and B both are prime numbers. For example, say P is equal to 11. 11 is a prime number. Q is equal to 5. 5 is also a prime number. What will be the LCM of 11 and 5? Definitely we need to multiply that, because no common factor other than 1. So we need to multiply non-commons. So 55 will be the LCM. For example, P is equal to 2 is a prime number and Q is equal to 7. That is also prime number. No other common factor other than 1. So LCM of 2 and 7 is 2 into 7, 14. 14 is the LCM. Likewise, P, A and B both are prime numbers. So LCM of the two prime numbers, nothing but product of the two prime numbers, A into B or AB. We can write it as AB. Suppose the same question, if they are asking they didn't ask suppose, they are asking HCF of this A and B, means because they are prime numbers, no common factor other than 1, you should not write 0. The common factor for two prime numbers, 1 is the common factor. HCF of these two numbers 1, LCM of these two numbers, product of that two numbers. Next case, a seminar is being conducted by an educational organization where the participant will be educated, will be educators of different subject. The number of participants in Hindi, English, mathematics are 60, 84, 108. That is, number of participants in Hindi 60, in English 84, and in maths 108. Then first question, in each room the same number of participants are to be seated and all of them being in the same subject. Hence, maximum number of participants that can be accommodated in each room. So, maximum number of participants accommodate in a room. So, we are arranging the participants. So, always arrangement means we have to find the HCF of three numbers. So, what are the prime factors of 60, 60, 230, 215, then 3 5s are. So, 2 squared into 3 into 15. Next number 84. Prime factors for 84, 2, 4 times 2, 2 to 21, 3 7s are 2. So 2 squared into 3 into 7. Now 108, prime factors for 108, 2, 5, 4, then 2 times 7 times 9 3s are So 108, 2 squared and 3 cube. Now when we are arranging this, we have to find HCF of all the three numbers. 84, 108 is equal to, so common factor, highest, least power. So 2 is common, from that least all the 2's are having same power, so 2 squared, and 3 also common, but 3 two different powers, 3 and 3 cube. Only we need to get the least power. So 2 squared and 3. We should not take non-commons. So 4 into 3, 12. HCF of these numbers 12. So minimum 12 participants can accommodate in each room, in each subject. So minimum 12 participants can accommodate in each room from the same subject. That is, in English 12 members and Hindi 12 members, Maths also 12 members can accommodate in one group. Now what is the minimum number of rooms required during the event? So what is the minimum number? Look at the participants. In first Hindi 60, English 84. That is the participant number of participant in Hindi 60. Number of participants in English 84 and in Maths 108. English 84, Maths 108. So previous question we found same subject, each room 12 participants can be accommodated. So for Hindi, how many rooms are required? So for Hindi, we have to divide the number of participants divided by our HCF. So 5 rooms. Only for Hindi, 5 rooms required. Then for English, totally 84 participants are there. When we are dividing that by 12, we need 7 rooms. 7 rooms for English to arranging the members of English. Then for Math, 108 participants are there. Divide that by 12. We will be getting 9 12s are 108, 9 rooms. Now total, what are the total rooms then required? Totally 21 rooms. So totally, to arrange these participants 12, 12, 12, we need 21 rooms. Then LCM of 60, 84 and 108. That is, once again we will write the prime factors. 108. Factor for 60, prime factors 2 squared 3, 5. So 2 squared into 3 into 5. Then for 84, 2 squared 3, 7. 2 squared 3 into 7. Then for 108, 2 squared and 3 cube. 2 squared and 3 cube. Now for common, here 2 power 2 is the common one, no highest, no least. So LCM of 60, 84, 108 is equal to 2 squared, and the next common is 3. So in this 3 power 3. So highest power is 3 power 3. So 3 cube. Then 2 non-commons are there, 5 and 7. So we have to include that non-common also. 4, 27 into 5 into 7. So we will be getting 3780. This is the product, this is the LCM. Let's we check this. 27 into 7 7s are 49, 180 and 2, 4 5s are 20. 27 into 7, 180, then 8, yeah, 370. So LCM of 60, 84, 108 is 3780. Next, product of HCF and LCM of these two numbers. So what we got, HCF of 60, 84, 108, we got 12. Then LCM of 60, 84, 108, we got, what is the number? 3780. 3780. They are asking product HCF of the three numbers into LCM of the three numbers. That is not product of three numbers. Only two numbers we can use that method. Here we cannot use. We need to multiply and check. Multiply and find. 16 remaining 1, 14 remaining 1, 6 plus 1, 7. So 0, 8, 7, 3. 0, 6, 12, 15, 4. So 45,260. This is 5, 60 plus a 5, 3. 45,360 is the product of LCM and HCF of these three numbers. Then next question, 108 can be expressed as product of its prime. As of course we expressed already, 108 is equal to 2 squared into 3 cube. So we can express 108 as product of primes. Next question, case 3. A mathematical exhibition is being conducted in your school and one of your friends is making a model of a factor tree. He has some difficulty and ask for your help in completing a quiz for the audience. Observe the following factor tree and answer the following questions. So look at the factor tree. Here you are having three unknowns, x, y and z. So how to find this? What are the questions? This is the factor tree. The questions are, what will be the value of x is the first question. So look at the factor 3, x 5 and 2783 are the factors of x. So when we are multiplying 2783 into 5, we will be getting the number x. So what is the product? 15, which is equal to 15, 41, 4, 9, 3, 13. So 13,915. So our x is equal to, answer for the first subdivision, x is equal to 13,915. So 13,915's factor 5 and 2,783. 5 is a prime number, but 2,783 is not a prime number. Once again, we can calculate the factors. Y and 2,500 and y into 2,503, we will be getting 2,783. 2,783's factors are these two. So to find y, we can divide it. 2,783 divided by 253. So So when we are dividing this, we can divide this one time and remaining 33. So again 1 times 53. So y is equal to 11. So answer for the second subdivision, y is equal to 11. Now 11 and 253 are the factor. 11 into 253 we are getting 2783. Now factor for 253 is 11 and some number, that is 253 factor 11 and z. So our z is nothing but 253 divided by 11. So 11. So we will be getting 22 times and 23 times. So the third question answer, z is equal to 23. So here 23. Now according to the fundamental theorem of arithmetic, 13,915 is a what? This this is z 23 into 11 into 11 into 5. So it's a composite number. Composite number because product of prime. We wrote here product of prime. The prime factorization of this is nothing but 13,915. Look at the tree. Z is 23. 23 into 11 we are getting 253. 253 into 11 we are getting 2783. 2783 into 5 we will be getting 13,915. So the prime factorization is nothing but 5 into 11 squared into 23. This is the prime factorization. Product of prime is a composite number, so that we conclude in fourth question it is a composite number. Thank you.